Hello, it's Andy here, and welcome back to my walkthrough of the 2019 Sans Holiday Hack. Objective number 9 is to hack into the student portal and retrieve the scanned paper scraps placed there by Krampus. But before we do that, let's head on over to the dorm and help Pepper Minstix. We can take advantage of the Steam Tunnels shortcut. Pepper wants some help with investigating the cyber attacks on Elf University and completing an incident report. The first question on the incident report form is what is the full path and file name of the first malicious document downloaded by Minty? We'll begin by logging into GreyLog and viewing the All Messages stream and showing the messages from all time, not just the last 5 minutes, which is the default. We can have a browse at one event to see what fields exist in the dataset and request quick values for the Windows log type field. This produces a nice summary of what log sources make up the dataset. Here we see a few different built-in Windows event log types, plus we have some sysmon events too. If the goal is to find a malicious file downloaded by Minty, we can start by looking for sysmon type 2 events. These are generated when a file is modified. Here I'm using the magnifying glass button to filter just the sysmon events, and then examining the first event to identify the correct name for event ID to add to the query string. Again, an examination of the first event is useful to see what fields are available for us to use. In this case, target file name contains the path and name of each file saved. It'll be laborious to have to expand each event, so we can tick the box next to this field on the left side to have it display at the top of each event. But we still have quite a lot of events to manually search through, so we can add a filter to our search string to only show items where the word downloads appears in the target file name. The logic being that if Minty downloaded the file, then there's a high chance it was saved to the downloads folder. We have two events of interest here, cookierecipe.exe and cookierecipe2.exe. Examination of each shows that the number 2 file was created by PowerShell.exe, whereas the other file was created by Firefox. So it's this latter item that Minty downloaded. This probably, amongst other things, launched some PowerShell code which was responsible for creating cookierecipe2.exe. We can investigate deeper to test this theory, but for now we have the name of the file to add to the incident report. Next, the malicious file downloaded and executed by Minty gave the attacker remote access to his machine. What was the IP and port the malicious file connected to first? Let's start by finding all events associated with cookierecipe.exe. Note the need to escape certain characters with slashes. We're also interested in sysmon type 3 events, network communication events. We're left with a single result which can be examined to identify the target IP of 192.168.247.175 and port 4444. This port is particularly suspicious as it's commonly used as the default port for Metasploit reverse shells. Let's add this to the incident report and move on to the next question. What was the first command executed by the attacker? If that connection was indeed some kind of reverse shell, we'd then expect to see new processes launched by cookierecipe.exe as the attacker executed various commands. We can see the process ID of cookierecipe is 5256, so we can pivot off that to find all events where the parent process ID is 5256. As we're looking for the first command which was run, it's important to sort by ascending timestamp. The default is descending. To avoid expanding each event in turn, we can again make life a little easier by adding the command line field to the view. This reveals the attacker's activity, the first command being "Who am I?". This is used to show the name of the currently logged on user, a typical move by an attacker who has just gained an initial foothold. Next up, we're asked to identify what is the one-word service name that the attacker used to escalate privileges. Continuing to browse down through each command executed by the attacker, we observe the use of sc to query which services are running on this machine, and a one-line PowerShell invoke web request command which downloads a copy of cookierecipe2.exe. This matches up with the earlier observation that this file was created by a PowerShell process. Shortly after, the attacker attempts to run cookie-recipe2.exe directly, and then a short time later uses SC to send a software update call to the WebEx service specifying cookie-recipe2.exe. This is a known vulnerability in the WebEx service, CVE 2019-1674, which allows privilege escalation to the system user. Pivoting onto the new process name shows the commands run under this new session, and the logs record that these commands were indeed running as the system user. Anyway, we have the answer to our question, so let's move on to the next one. What is the file path and file name of the binary run by the attacker to dump credentials? Continuing to review the commands executed by the elevated cookie-recipe2.exe process highlights a series of invoke web request calls to download Mimikatz and several of its dependencies onto this machine. Mimikatz is the classic tool for dumping credentials from Windows-based machines. The first call is to the project's GitHub page, but we might suspect this failed. Perhaps this machine has no direct access to the internet, as it's then followed up by a similar call, this time downloading from our attacker's IP address. In an attempt to look a little less suspicious, the attacker saved the Mimikatz executable as cdrive cookie.exe. The logs then record this program being executed with the relevant arguments to dump the credentials of users who have previously logged into the workstation. Next up, the attacker pivoted to another workstation using credentials gained from Minty's computer. Which account name was used to pivot to another machine? There aren't any other events associated with the cookie recipe processes, so it's unlikely the attacker pivoted onto another workstation from this one. They must have used their previous foothold at 192.168.247.175, where we saw Mimikatz being downloaded from. So let's examine all events which record this as a source IP, and show quick values for log source. All of the previous investigation was on events from Workstation 1, but this summary shows that Workstation 2 also received traffic from the attacker. We can filter on just that, and show quick values for destination port to get an idea of what sort of communication occurred. This indicates traffic on port 445, Windows File Sharing, and 3389, RDP. So the remote connection mentioned in the question is probably relating to the remote desktop session. So let's search for all logons on this box around this time. Logons are recorded as Windows Event ID 4624. We'll reorder the events and tweak the columns on display to include source network address and account name. And here we see successful logins to this machine from the attacker's machine using Alabaster's username and password. The login type for this event is 3, a network login. However, remote desktop logins should have an event type of 10. Adding this to the query string highlights a successful RDP connection. Next, we're asked to identify what is the time the attacker made a remote desktop connection to another machine. Well, our previous query already shows the RDP connection occurring at 4 minutes and 28 seconds past 6 o'clock in the morning. The attacker navigates the file system of a third host using their remote desktop connection to the second host. What is the source host name, destination host name, and logon type of this connection? We can repeat the process we just went through for this question. Start off by looking for all logins, event number 4624, where source network address is workstation number 2, 192.168.247.176. A quick view on log source shows all events came from workstation number 3. This must be the third host mentioned in the question. There's only 4 events, so we can sort them oldest first, and tweak some of the display columns again to show the fields required for the incident report. The logon type of 3 suggests this was a Windows file sharing connection. Next, we're asked, what is the full path and file name of the secret research document after being transferred from the third host to the second host. So this question is specifically asking about the file name and path after it has been transferred, so we need to focus on events from workstation number 2. Sysmon event type number 2, file time modification, should give us the info we need. There's many items that don't seem that interesting, but down around the 7 minutes past 6 mark, there's a record of Explorer.exe creating a file called Super Secret Elf Research on Alabaster's desktop. After adding this to the incident report, there's just one more question to go. What is the IP address, as found in the logs, that the secret research document was exfiltrated to? Examining process creation events after this time might give an indication as to how the document was exfiltrated. And it looks like PowerShell's invoke web request commandlet was again used to send this document to the pastebin website. This process has a process ID of 1232, so we can pivot off that and change the event type to 3 in order to see its network traffic. And there in the logs is the IP address 104.22.3.84. With the incident form complete, Pepper thanks us and gives us access to a couple of hints. Now to the main objective: break into the student portal and find the scraps of paper. Let's take an initial browse through the site. We have a landing page, a page which lists the elves on the student body, an application form, and a page to check the status of applications. We can also tell from the URL that this site is running on PHP. A quick browse of the page source doesn't reveal anything obviously interesting in the landing page or the student body page. In the application page, we can see that form data will be processed by applicationReceive.php, and there's some JavaScript which is making a call to validator.php. It's a similar story in the Check Application Status page. Let's make a quick application with some dummy data. This appears to be accepted. And if we check our application status, we're told that it's pending. Okay, time to poke a bit harder by submitting a new application, this time throwing in a few quote marks to test if the page might be suffering from a bit of SQL injection. It looks like it does, as we're presented with a lovely error message, complete with details of the SQL code being executed, given a good view into the structure of the database tables, and also telling us that the database is running on MariaDB. This gives us a possible path forwards. Presumably, we'll be able to access the portal if we enter an address in the check status page which has been accepted or approved, rather than pending as is shown in the SQL error. We might be able to do that by either A, dumping the applications table to find an approved user's email address, or B, adding our own email address but forcing it to have a status of accepted. Although we still don't know what that value should be. Accepted, approved, authorized, etc. We'll just have to guess and trial and error. Let's see if we can do option B. We'll fill out all the fields in the expected way, apart from the essay field, where we'll overwrite the rest of the SQL statement with a custom value for the status field. The double dashes tell the database to treat everything following it as a comment, so is effectively ignored. Let's give it a try. The absence of any error suggests that we've been successful. From the check application page, we see our application has been processed, but sadly it provides no means to log into the site, nor is there any sign of Krampus's hidden paper scraps, just a nice little troll from the challenge designers. Okay, next thing to check is to see if we're able to write any files. If so, we might be able to drop a web shell onto this server and access files that way. Writing files is achieved in MariaDB via the select into dump file statement. We've already seen that the submit application page uses an insert statement, but it's a good bet that the check application page is using select, so let's switch our attention to that, assuming that it's also vulnerable to SQL injection, that is. We'll check by submitting just a quote, but there's some client-side JavaScript limiting us to only submitting an email address. But this can easily be bypassed by using the browser dev tools to remove type equals email from this element. Whilst we're here, we can examine the validator code a bit more. This looks to be making a GET request to update a token. Indeed, if we navigate to this resource and refresh a few times, we see a different token. But back to our attempt. We get confirmation that this page is also vulnerable to injection, so we can try writing the output of the query to disk. But we receive an access denied message. It looks like we don't have database permissions to use the into dump file statement, although at least we do now know the username for the database, elfu, and that this user can log in from any host, the % symbol. So one of the hints that Pepper gave us was about SQL Map. This is a tool which automates the scanning and attack of SQL vulnerabilities. Let's start by asking it to examine the check application page. We need to provide it with knowledge of the page parameters, elfmail for the email address, and token for the validation token. Part of the challenge is that the validation token is only valid for a few seconds after it is obtained, so we need to get SQL Map to fetch a new one for each request it makes. Pepper had hinted that this could be achieved with a custom tamper script, however it's far easier just to use the eval command line argument to run a small snippet of Python. In this case, to overwrite the value of token with the response from an HTTP request to validator.php. This takes a while to run, but it confirms our manual tests that a SQL injection vulnerability exists, specifically blind SQL injection. In a classical SQL injection vulnerability, an application provides a mechanism for the full response of a SQL injection to be visible by an attacker. Blind SQL injection, by contrast, only allows an attacker to determine whether a given statement is true or false. This limits the options available to an attacker and also means that extracting data can be painfully slow and complicated if done by hand. Thankfully, SQL Map helps automate the process of exploiting blind SQL injection. For example, the OS shell argument attempts to create an interactive shell to the server. This ends in failure, which is unsurprising really given that it needs to be able to write to the server, and we've already suspected that our database user doesn't have sufficient permissions to do that. But SQL Map gives us a few other options too, including the ability to dump the database. We can start by extracting the schema. There's a table called Krampus. This could be what we're after. Let's dump it. This looks like parser images stored on the server. This could be Krampus's scraps of paper. We can download each, and opening them up reveal them to indeed be the paper scraps. Reassembling these reveal a message disclosing an evil plan to destroy Christmas by tampering with Santa's new sleigh guidance technology, leaving him unable to deliver any presents. One scrap of paper appears to be missing, which would contain the name of the villain, although the large tooth-shaped watermark suggests this may be someone with links to dentistry. We can submit the answer to complete this challenge, and quickly check back in with Krampus. He gives us an encrypted document which he thinks is connected to the evil plan to destroy Christmas, but we'll get to that in the next episode. I'll see you there.